During the early morning hours of January 19, 1965, at Pad 19, Cape Kennedy, Florida, the countdown began for GT-2, the second flight test of the Gemini program. This flight, an unmanned suborbital flight, was to be one of the most crucial in the Gemini program. It was designed to flight qualify the spacecraft and launch vehicle for manned spaceflight. In this mission, vital information would be gained on re-entry heating and heat protection, spacecraft equipment would be checked for proper operation during flight, and information necessary to ensure safety of the flight crews on future manned Gemini missions would be obtained. The spacecraft for this mission was manufactured and assembled at the McDonnell Aircraft Corporation, St. Louis, Missouri, prime contractor for the Gemini spacecraft. The launch vehicle, a modified Titan II, was developed by the U.S. Air Force and the Martin Company, Baltimore, Maryland. The final checkout of the spacecraft and launch vehicle systems proceeded normally, and approximately 90 minutes before liftoff, the spacecraft hatches were closed and torqued. The white room at the top of Pad 19 was then dismantled in preparation for lowering of the erector. As the countdown proceeded, pad personnel left the area and the erector was lowered. Meanwhile, at the Mission Control Center, flight controllers closely monitored spacecraft equipment and completed final preparations for the launch. Instruments were set to record the flight trajectory and other vital information which would be transmitted by telemetry from the spacecraft during flight. Monitors in the blockhouse checked and double-checked their instruments, maintaining close control over the launch vehicle which would propel the spacecraft downrange for this vital test. At approximately 4 minutes past 9 a.m. Eastern Standard Time, the Gemini launch vehicle lifts from the pad and begins the powered phase of the downrange flight. Seconds after liftoff, a white vapor trail marks the path of the vehicle through the atmosphere, ending near the spot that the vehicle reached max Q, or maximum dynamic pressure. Some 2.5 minutes after liftoff, the booster engine cuts off and staging occurs. The sustainer engine then takes over to propel the spacecraft to a maximum altitude of 98 9/10 statute miles and a top speed of 16,708 9/10 miles per hour. After separation from the launch vehicle, the spacecraft orbital attitude and maneuvering system thrusters fire to turn the spacecraft in orbit to blunt end forward. The adapter equipment section is jettisoned. You can see the adapter, the light object, float away from the spacecraft. From a camera mounted in the command pilot's position on board the spacecraft and reproduced here at 4 times normal speed, observe for the first time the extraordinary phenomenon of a spacecraft re-entry, a view hitherto seen only by a handful of U.S. and Russian space pilots. In this first out-the-window film record of a spacecraft re-entry, the spacecraft is oriented to the proper retrograde firing attitude. The retro rockets are fired automatically in sequence to slow the spacecraft and begin the re-entry phase of the mission. After retro firing, the retro adapter section is jettisoned and the re-entry control system thrusters fire to place the spacecraft in a constant roll rate of 15 degrees per second. The thrusters are directly in front of you in the neck of the spacecraft. Notice the white shafts of light as the thrusters fire. The roll rate stops, and the 6-foot pilot parachute deploys, pulling away the R&R section and deploying the main parachute. The spacecraft shifts from a 1 to a 2-point Gemini-type chute suspension and gently floats to the sea below. The spacecraft landed in the prime recovery area about 20 miles west of the Navy carrier Lake Champlain. It had traveled a total of 2,127 statute miles in just over 19 minutes. Department of Defense recovery forces, already deployed along the flight path, immediately go into action. U.S. Navy swimmers and their equipment are dropped at the scene by helicopters from the recovery carrier. The equipment includes a flotation collar, which is attached to the spacecraft to provide additional buoyancy until the spacecraft can be lifted out of the water. Meanwhile, other helicopters search the surrounding area for the rendezvous and re-entry module. This section, lined with buoyant material, was recovered about a half-mile from the spacecraft, an extra bonus in the Gemini 2 success story. Then the Lake Champlain pulls alongside. A huge crane swings out over the spacecraft, and at 10:45 a.m., just an hour and 41 minutes after liftoff, the spacecraft is hoisted from the water. The flotation collar removed, the spacecraft is placed on a special dolly on the deck of the carrier to await return to Cape Kennedy for complete analysis and inspection. Gemini 2, the re-entry mission to qualify the spacecraft for manned flight, is complete. Visual inspection on board the carrier indicates mission success. Mr. Charles W. Matthews, Gemini Program Manager, had this to say about the mission. On the basis of first-look information, we foresee no trouble that would hold up the first manned mission.